Thanks for joining this session. My name is Yulei Zhang. I'm working for Tencent Cloud, which is one of the leading public cloud providers. Xiao Guangrong is our open source leader who was initially this idea. But due to the travel conflict, he cannot make the trip to Edinburgh. So I will present this topic on behalf of him. And after this section, if you are interested in this topic, you can reach us through the email address. Any questions or suggestions are welcomed. This is our agenda for today's topic. At first, we will talk about the status of current line migration, and then we will elaborate the adaptive line migration we proposed to improve the migration success rate in details. And at last, we will discuss the works need to be done in the future. I think we all know the importance of line migration in cloud usage. As you can see, just this afternoon, we have several topics about line migration, and I just heard about another public cloud provider use FFT to predict workload in cloud. That's very interesting. And as we know, so far the new cloud usage, such as data learning, deep learning, data mining, and other memory-intensive workload are bringing challenges for migration. The memory dirty rate may be much faster than the networking transfer speed. And also, I/O-sensitive VM requests extreme low downtime and low latency. So we think there should be more, something in improvement needed in this area, and come up with this idea, which called adaptive line migration. And in this slide, I want to emphasize what Tencent Cloud has contributed for the line migration in the past. The first one is what we lectured in last year QEMU forum, which is presented by Xiao Guangrong. It's called the faster write protect and the faster dirty log bitmap sync-up. And the second one is also presented by Xiao Guangrong in this year's Asia LLC. You can find the details through the link. Then let's talk about the shortcomings in current line migration. As we know, in PreCopy memory migration, the hypervisor typically copies all the memory pages from source to destination while the VM is still running on the source. If some memory pages changes during this process, they will be recopied until the rate of recopied page is not less than the page dirty rate. So far, there is existing optimization methods such as memory compression, XBZRLE, but due to the workload differentiation, as I said before, currently no optimization is all purpose. So let's go through them one by one. The first we'll talk is auto-converge. Auto-converge is dynamically throttle the vCPU to force the VM to dirty less memory. But the disadvantage is obviously as it would make VM completely unusable if the migration is remaining unsuccessful. And also, it may cause big latency to handle I/O request for the VM. For example, it may lose Ethernet packet, cause ping failure, and bring bad user experience to customers. So from this fact, we may need to put I/O status into consideration before we want to enable the auto-converge in line migration. Then is the memory compression. During the PreCopy, it will use multiple threads to compress the data before post them to the network. And we can see the disadvantage of memory compression is it will cause highly CPU usage, and it depends on if the memory is compressible. So in order to use the compression, we may put the system CPU usage and the guest memory status into consideration. XBZR is also a kind of compression. Instead of sending the changing guest page, it will send a compressed version of updated in guest pages. But there is also disadvantages. It requires additional system memories. And due to the migration, the system resource may be changed all the time. So if it becomes out of system memory, it is not appropriate to enable the Expedia LE. So, and it may cause the compression very hard to finish. So we may put the following two factors into consideration to enable the Expedia LE. That's the VM memory is friendly to Expedia LE and the system memory usage. Okay, the last one is the Postcopy. Postcopy means the VM starts running on the destination host as soon as possible, and the RAM from the source host is paging forward into destination over time. The disadvantage to use Postcopy is during the Postcopy, sometimes it has to suffer the poor performance because we need to wait the memory copy from the source host. And if there something happens during the Postcopy, we may not be able to recover the VM. So to our perspective, the Postcopy will be the last choice for live migration. Based on this description, we can understand how to successfully and safely do the live migration. There are two things are certain. We need to try the best to make PreCopy success, and it is better not to use the Postcopy. In order to achieve this, it comes out our proposal to enable adaptive live migration, which will provide a higher successful rate and a better user experience. So what is adaptive live migration? It has 4 steps. At first, we will speculate the workload in the VM from the host side to get information such as dirty memory rate, VM IO statistics, and then, second, adaptively enable or disable the optimization methods such as compression, auto-converge, and XBZR-LE. And after enable the optimization method, we will dynamically fine-tune the parameters of it to make the migration successful. Last, if there is no way to make the PreCopy successful, we will turn on the Postcopy. This is the overview picture, shows the migration path of adaptive live migration. So you can see in the PreCopy stage, we will try different optimization methodologies to make sure the PreCopy will success. But unfortunately, if the PreCopy is not success, we have to enable the Postcopy to help the migration success. This is the architecture diagram of adaptive live migration. You can see we introduced the adaptive live migration control daemon in the backend to handle the magic. Inside it, we have 2 major components. One is called the tenancy detector, and the other one is called the performance accessor. As you can see, the tenancy detector will fetch the runtime status of migration. If the migration cannot be success, it will ask a performance accessor to try different optimization methodologic. Oh, sorry. And meanwhile, the performance accessor will select the information from both tenancy detector and the host system, and rely on this information. It can fine-tune the parameters or disable or enable the optimization. This is the tenancy detector. Tenancy detector will dynamically detect if migration can success based on the performance statistic of migration. Currently, we use the dirty page rate. You can see from the picture, if the dirty bit rate become diverging, means current migration cannot be success. and we need to try something new until the tenancy becomes converging. This is the flowchart about performance accessor. As we can see, so after we enable optimization method, we will tune the parameters for it, and we will check if the migration can be successful. If not, we will check if we have tried all the optimization method. If not, we will choose another one. And after that, if we have used all the method, we will have to enable the Postcopy. And probably we could use the optimization method in an order like, at first we will try the auto-converge, and then the memory compression, and then the Expedia LE. This diagram shows how we plan to select the system and the VM information to fine-tune the parameters for memory compression. For example, from the system side, if the network speed is fast enough for normal guest page transfer, then we don't need to enable the compression at all. And we also collect the host CPU usage to decide how many compression threads we could use to create and choose the proper compression level. For the Expedia LE, it's the same. We could collect the system memory usage from the host side based on to choose how many threads could use to do the Expedia LE and how much the Expedia LE cache size could be. And for the auto-converge, recently there's a new parameter is introduced called the max CPU throttles, which is prevent to squeeze the guest CPU too much and make the VM completely unusable. But in addition, we think based on the I/O status of VM, instead of kick the vCPU out of execution and sleep the vCPU thread without interrupted response in user space, we would like to block the vCPU in the QEMU module so that it could still respond to the I/O request in time. So any question for this? No. So last, we will talk about the future works and what we have done and we would do to optimize the live migration. For example, we introduced a lockless multi-thread mode for memory compression, which is implemented based on the PTR ring. And also, we increased the job request number for each compressed thread, which has proved to be much more efficient during the migration. And for Expedia LE, we would like to also introduce the multiple thread mode for it, but which is currently not supported in upstream code. And we will do more tests to enable the dynamic parameter adjustment and finally integrate them into the adaptive live migration control demo. That's all from me. Thank you. So any question? Yeah.
Very cool.
Thank you.
The auto-converge, what mechanism do you use to attenuate CPU speed, vCPU speed? How do you slow them down?
Slow them down? Just kick them out of the execution, but we still keep it in the QEMU module, in the kernel module. So it's use the vCPU block method. So it can still respond to the external interrupt. And after it gets interrupted, it can go back to the VM to finish its job, and then we will kick it out again.
Did you add a new ioctl to do that?
I think we will add a new I/O control for the KVM CPU KVM, to do that.
Thank you.
Have you tested multi-FD, the new code that there is in QEMU for that? Multi-FD, a PreCopy with several streams at the same time.
Excuse me, you what in QEMU?
There is a new code that I wrote that it was multi-FD that allows to do migration with several streams at the same time. I guess way faster than what we have at the previous PreCopy. If you have the chance to test it on your workload.
Yeah, we are working on it, I think.
Last time I looked at the way QEMU throttled the CPUs for the auto-converge.
Mm-hmm.
It actually had a timer, and then it introduced some sleeps before scheduling the CPUs.
Mm-hmm.
And that was global for the VM. When I looked at it, one of the things that looked like it could help a lot would be to make the timer per vCPU, because there were problems to do with the CPU scheduling.
Mm-hmm.
If you slept too much, and then the CPUs would either run and not respect the throttle, or not run and sleep too much. Is that something you encountered at all, or is that something in your list of maybe future works to look into?
I think definitely we will look into that, and I hope to talk with you offline about this.
There's also been a recent paper by Google. I was trying to find out where it was published. I think it was on VE18, where they did some similar study on when to pre-copy, when to post-copy, and how that works in their cloud. Did you have a chance to compare your work to that?
Not yet, but if you can point me to that, I will
Sure.
appreciate it.
There are no other questions. Thank you.
Thank you.